I love looking at you from up here. It looks really impressive. So you're going to have two Australians back-to-back talking to you, so you're going to be sick of us by the end of it, and our accent, or you'll start talking like it's one or the other. It usually happens. For those of you who haven't met me or you haven't listened to me rant on up on the stage before, I'll give you a little bit about me. I'm 23 years old, and there's a lot to me aside from being a developer. I've got a girlfriend called Jess, and she's amazing. We've been together for 4 years, and I've got a cattle dog, and we go running in the bush a lot. It's one of my favourite little pastimes. Aside from that, I'm into mountain biking, okay? And that does look a bit weird, but I'm also into scuba diving, all right? And I think if you're efficient and you want to, don't repeat yourself, you can be a scuba biker, right? So it looks a bit stupid, I know, but it's fun. Another little hobby I've been doing martial arts for a little while, so I'm kind of all into that sort of junk as well, but it's good fun, keeps you fit and gets your mind off work. And also, I'm a developer. Okay, so I run an agency in Australia called Webcom. We do a lot of websites, naturally. we do e-commerce and that sort of stuff. It's really fun. And finally, I'm a bit of an addict for Laracons. I did a quick tally, and it's around about 132,000 kilometres I've travelled in the last 2 years for Laracons, which equates to around about 200 hours sitting in a plane seat. So I like these things, and they're good fun because you get to listen to lots of awesome talks, and on the odd occasion me. So, and there's a little bit more information. If any of you want to scan the thing, you can. I dare you. All right. Search. So search is it's a bit voodoo or a bit taboo maybe, in the sense that people don't really like to think about it. It's one of those things you just sort of. It's a bit like validation actually in that sense. It's like you just put it to the side and don't worry about it. Just hack something together, but really it's filtering information and determining relevance. That's all there is in search. There's not a lot. So the rest of the talk is we're going to deviate from this scenario, but the rest of the talk is going to sort of work towards this one relatively simple scenario that it's kind of hard to model, okay? Seems simple, but when you think about it, to do a really good experience, it requires a bit of thought, okay? So here's a scenario. Sorry for the wall of text. There's not many slides this bad. Okay, so I'm a person and I'm going to Laracon and I want to stay at Renaissance hotels because I like them, but they have to be within 500 metres of BIM House, okay? Because I want to be close and I don't like walking. So the hotel needs to have disability access, okay? And in a perfect world, it's going to have Wi-Fi and I want to be above ground level because I like the view, okay? Pretty simple requirements, but when you think about it, there's actually a fair bit happening there, all right? So we'll come back to that. We'll talk about some other stuff first. But you've got to sort of define what's required and what's sort of an optional thing, because, I mean, at the end of the day, you don't want everything to be required, because if you're trying to search and, one thing doesn't match the criteria, well, you're kind of up a creek, okay? So the name of the hotel is Renaissance. 150 euros or less is what they want, okay? Within 500 metres of BIM House and disability access. Now, I've put down the bottom that these perceived requirements actually are optional if you think about it, because, well, have a think about it. We'll come back to it. Just have a think about why you might not want to make those those requirements so strict, okay? And of course, Wi-Fi, and they want to be above ground level. And yeah, insert cheesy joke, okay? Yeah, so at the end of the day, this is something that really bothered me with everything. I've been developing for not very long, since 4 years or something like that. So since I was about 5, but at the end of the day, if search is filtering information and determining relevance, right? And humans, we don't think like so robotically, right? We think quite laterally. Things come into our head, all this sort of stuff. Then why are our apps so robotic? Okay. A lot of things can be, but when you're searching for stuff, particularly if you want to make a nice interface that's simple for your users, we need to really tailor our apps to our users. And there's really one key thing that you need to do, really, and that's use the right tool set and know your data. Okay, that's the only way you can really pull off search well, is to have specific specific filters and operations and all this stuff are happening under the hood so that your users don't have to think smart, they can think really dumb, okay? And so that's why I'm here to talk to you about ElasticSearch, okay? It's a really cool little thing. Has anyone actually, like before I talk about this, I just wanted to say, who's used ElasticSearch? Most of you. Wow, okay, this is intimidating. Who uses it a lot? Who knows a lot about it? Oh, balls. All right, cool. Well, I can't lie then. Okay, so in a nutshell, ElasticSearch is a search engine, okay? But it actually can be used for more than just that. It's really good at analytics. The way it does its stuff, we'll talk about that soon, makes it really good for analyzing data like, aggregating totals and sums and which are the same thing, and averages and things like that, and finding out information for reports, faceted search, things like that. It's object-based, okay? For those of you who were sort of here yesterday, or not here, down the road for the community day, we had the talk on Neo4j, and it's that was really interesting for me because it's something I've never even put any thought into, and that was really interesting to learn about. And this is sort of like that because it's so different. If you haven't dealt with anything but plain old like MySQL, it seems intimidating, but it's cool. And it's distributed by nature. So from the ground up, it was designed at scaling. Okay, MongoDB web scales for the win. But it's like that. Okay, and hopefully it doesn't get the same stigma about that. What I wanted to do though, before we really dig into how Elasticsearch works, I just wanted to sort of give you, this isn't really a SQL versus Elasticsearch as such, it's more like, in SQL I do this, therefore in Elasticsearch I do that, right? So it's sort of just like transitioning you into it, especially if you haven't seen it before, okay? So yeah, SQL is a relational database, whereas Elasticsearch is a search engine. I've said that, but it's really sort of core to it, I guess. SQL is brilliant at filtering at a binary level. So, for example, something is something there, and it matches, or any of that. Elasticsearch is really driven at how well something matches, and that's probably the biggest fundamental difference between Elasticsearch and some other search engines, and your plain old SQL sort of databases. Okay. Don't get all weird about the full text stuff in SQL. We'll come to that, and we'll quickly go past it. All right. The third point I've got here about Elasticsearch but needing to be synced, this is the case if you're not using it as a primary data store, but there actually are people using it as their main data store for their entire apps. But you can actually synchronize all your data into Elasticsearch, through, well, I've got an example coming up with Laravel, how you could do such a thing, and then use that data to query and against and all that sort of thing. Because Elasticsearch is magically configurable to sort of scale, it means that you don't have to worry about bottlenecks or anything like that, which is kind of nice. Here I've got a pointer up here, don't I? I do. So in SQL, you've got a database which contains one or more tables, which contain rows in the tables, right, or entries. Elasticsearch is pretty similar. It's comparable, at least when you look at it on the surface, where you have an index, which kind of relates to a database, okay? And then you have a type, which is kind of like a table. So it could be users or places or, events or something. And then you have a document, okay? And the document is basically a row, all right? But it's a bit more fancy than that. Okay, so digging in a little bit further just into Elasticsearch now. It's document oriented, so it's not just you have a row that has a field and then it has a value for it. It's actually really quite nice, and it uses JSON, which I love. Okay, not enterprise ready, but it's okay. All right, because the data is JSON, and it's built around using JSON data. Nested data works wonderfully too. So you can have relationships within a document, right? So not in a separate index, but within the one document, you can query against them. You can do all sorts of nifty things, and it doesn't sort of impact on the performance the way it's structured. So just to give you a bit of an introduction to what an object may look like in Elasticsearch, it's basically just a JSON object, right? You can have your plain old strings and things like that, or you can have arrays, you can have integers, anything. It's pretty good. So at this stage, when I was first reading this, I thought, oh, this is cool. And then I found one big problem. All right. So don't tune out, okay? but you can sulk quickly for 3 seconds. I'll look away and then you can come back and we'll continue, okay? So cue the sulks. There, it's not that bad, is it? All right, moving on. Installation's pretty easy. You just have to have a Java runtime on your computer, and I think it's 6 or 7, I don't know, anyway, something. You download and install ElasticSearch, and it's in 3 commands. It's like running Beanstalk or something like that. If you ever just downloaded the binary and you run it, that's all it is. There's heaps of Ubuntu distro packages and things like that, and there are Puppet and Chef scripts available. And I dare say there's probably an Ansible script available, I would imagine, or a playbook. Scaling isn't scary. I hate server admin. I really hate server admin a lot, but scaling Elasticsearch is one of those things that is just so ridiculously easy. You just start another instance, and as long as you've set them to listen to the same things, they just work. What's really cool about it is you can, and they're called nodes, okay? An instance of Elasticsearch is called a node, and you put them together, form a cluster, all right? When you talk to it, you can talk to any node and it can do anything. It can take the request, it can load balance, it can do all those sorts of things. When you're scaling, they're good for redundancy because the way it structures its data into things called shards, which are like partitions, but very long and boring and horrible, but it means that different bits of information are spread across different nodes, and it's all automatic. You don't have to do anything to configure it. And it makes things faster and more backup safe, I guess, or redundant. Just as a quick note, this is completely off the topic of just Elasticsearch, but I always found it intimidating. Because I don't like server admin stuff, I always found the whole horizontal and vertical scaling thing intimidating, okay? So anyone who's confused by it, here's a really quick, dumbed down view of it. Okay, so horizontal scaling is talking about adding more servers, all right? So you just we could put all of our Macs together and we'd have one, super Mac or something. That's horizontal scaling, okay? Vertical scaling is increasing the resources on an individual server, okay? So that's just a bit of a detour, but it is important, and I've never really understood it. I used to say I understood it, and yeah, I just was sort of lying. All right. It's one of those. So if someone out there didn't understand it, I may have taught you something, if nothing else. All right. Now, coming back to Elasticsearch, it actually uses a RESTful API, which is really nice too. So we're talking about JSON over REST. This definitely wouldn't be enterprise ready. But for me, that is a big win. Okay. It's so simple. Any client can talk to it, right? As long as you can perform a HTTP request, well, then you're good to go. So it's a bit like this, all right? In fact, it's like any RESTful API you've ever dealt with. You hit an endpoint with a HTTP verb. So a GET request could be to get some information, POST or PUT could be to tell it some information, and delete was to delete a resource. So we'll come into a lot of detail with this sort of thing soon, but just understand that there's nothing magical about it. It's just a REST API, okay? So creating a document would look something like this. If we were making our back to our original question for our hotels, we were putting in some documents. We might have our app as our database name, okay, or our index name in Elasticsearch. We have a hotel, which would be it's the document type, right? So it would represent the equivalent MySQL table name. And then we've got our payload, okay, which is basically the same thing I showed you earlier. Okay, we're putting all this information into it, and that's it. We just push it up, and we'll get a 204 created response, and we're good to go, basically. It will give you 409s if you've got conflicts. It'll give you 422s, I think, if you've got validation failed, because you can define a schema, but we're not going to talk about that in this talk. That's for another day. Those of you who are actually interested in it by the end of the talk, you may want to have a look at it. The rest of you may hate it by the end of the talk. We don't know. Same thing to update. Okay, so you just hit a put request and you send a new payload up to the server for that particular item, and it updates it. Okay, and of course deleting. All right, is pretty simple. All right, so. What else? There's more to documents, and we're not going to cover it today because I don't want to give you a massive information overload. So we've got partial document updating. Okay, so the updating that we were talking about, you have to send through the whole new payload of the document. You can just send through key value for the items that you want to change. Versioning is really important of documents. It's not scary. Every time you update or create a document, it gets a version. And because Elasticsearch is distributed, right, when you update a document, it updates it wherever you tell it to do it, and then it sends all that information out across your big cluster of servers. If, for say, you update the document twice at the same time on 2 different servers, which you can do because it scales nicely, you could override the other person. So you can actually say, when you're updating a document, this is the version I had, this is the new stuff, and it'll go, hang on, no, that's not going to work, and it'll give you a 409 conflict. Out of the scope of this talk, but just be aware that it is there, okay? What else? Yeah, and there's bulk methods too. So if you're indexing, and this is where Elasticsearch shines, when you've got lots of data. If you're indexing 100,000, 200,000 records, the most I've done was about 300,000, so not into the millions yet, but it was a fair few. You want to be doing that via bulk methods. You're sending a batch through at a time rather than just sending individual ones, because you don't want that concurrent request blocking your I/O. All right, not the I/O, you blocking your app. So I think Elasticsearch makes searching fun. All right, it does. It is actually kind of fun to use, I find. So the reason it's fun is because it's easy. Every field is searchable. All right, every single field that you put into Elasticsearch can be searchable, that is. You can block them from being searched, and there's reasons as to why you would. You can perform structured queries, which is your full text, like how well does this match, or you can perform filters against any of those fields. Your queries and filters are also JSON, so the whole process is using JSON, okay? And the results come back according to relevance. You can order by other things as well, but relevance is like the coolest part. I'm going to talk a little bit. This if you're not into it, this part, feel free to tune out for 10 seconds if you don't want to learn Elasticsearch. I'm going to talk about 3 things. Okay, indexes are noun, indexes are verb. That's really important to get the differentiation right, because otherwise you got this word. The terminology is a killer. I think that terminology is usually the biggest barrier of entry. So you have indexes and noun. Okay, that's talking about a database. Right, indexing as a verb, right, is referring to putting something into the database, okay? And then we've got this other one called an inverted index, and that's something that if you haven't dealt with a system like this before, you'll have probably never heard of. It's really cool. It sort of completely flips on the head everything you thought about how data should be stored in the database, and it's the reason Elasticsearch is so powerful. To get things into an inverted index, it's just a key value list of what terms are in there, what documents they are. But to get things in there, we need to actually analyze the text that comes through, okay? So say you've got a bunch of blog posts, and the first post is my favorite thing to do, whatever. My favorite thing to do. And what you're going to do is you're going to apply character filters to all of the data you enter. So you'll strip out funny. You can strip out funny characters, ampersands, all these sort of things. All these things are optional, but they come default into it. And then what we do is we split all of those words up into terms. So every individual word would become a new term, right? So you think about it, we've exploded by white space if you're talking in PHP terms, okay? Then we use token filters, which take these terms and manipulate them. Okay, and this is why you have such powerful ability to search related terms, words you didn't quite spell right, all that sort of thing, because we can normalize things, make them lowercase. What else? We can remove stop words and add synonyms. So, for example, you were saying, I like to jump around the stage, right? You could say, I like to leap around the stage, and that should still be the same thing, because jump and leap are, for the most part, the same thing. And if you're searching for one, you by all right should find the other. All right. Analysis is really configurable. Multi-language support. I think 33. All right, 33 languages. It's really cool. And anything that's not indexed is not searchable. And it's important to note that when you're indexing, you're doing this analysis process to put it into an inverted index, but you've also got to do it when you search, because it's got to match up. So an inverted index for these 2 sentences, the quick brown fox jumped over the lazy dog, and quick brown foxes leap over lazy dogs in summer, it's going to grab these terms, okay, It's going to normalize them, lowercase them, make sure there's nothing funny, no funny characters in there or anything like that. Then it's going to separate them out by individual terms and make sure that we're accounting for things like synonyms and all this using our analyzers and all this. This is all automatic, by the way. This is just like an FYI how it works. And we build up something like this. This is an inverted index, okay? Everything in ElasticSearch runs off an inverted index, okay? So you have every single term that exists and the documents which match it. That's all it comes down to, okay? The reason that's really powerful is because we can search a particular word and we know how many documents refer to that word, and that's the fastest way of doing it. And by doing that, we can work out which documents are most relevant, all that sort of thing, and that process is called scoring. Okay, so once we're searching through, in this example, we might want to search for summer foxes. Okay, if we was to search for summer foxes, both contain fox or foxes. Okay, so both are going to get a point for that. But document 2 has summer, so it's going to become more relevant. All right. Searching. Once you've done the search, you've got the scoring, and that comes down to primarily 3 things. One's called term frequency. That refers to how often that term, fox, maybe, appears in that particular field. All right. And then the next one is how often that term appears in all of your documents. Because if you have something that appears in every document, it kind of becomes irrelevant, right? Because it loses meaning. You know, it's a bit like the boy who cried wolf. It just loses meaning. And the other one is field length norms. So if you have a title that has 200 words in it, each one of those words is kind of less important than a title that has 4 words because they give more meaning within the scope of that document, right? So moving forward, yeah, fields are also boostable. So this gives you a lot of power to when you're searching, right? It lets you say, oh, I think the title's more important than, say, the company, or I think this is more important than that, and lets you customize and tweak how relevant results are, okay? You've got things called functions, which lets you weigh different things higher and lower according to criteria that you might define. An example, hint, hint, could be maybe how far something is away from another place or a price or something like that. And of course, you can alter all this. You can really customize this for your specific use case, okay? Queries and filters in ElasticSearch, I did say they're both JSON, okay? And they're very modular, so you just have these little blocks and you insert them into each other and they kind of work. The problem is they're a bit verbose when you first look at them, so you just got to sort of get past all of that. But you put all these things together and it's called the ElasticSearch Query DSL, okay? You'll hear that referred to a lot if you start getting into ElasticSearch. That's the language in which we talk to, but it's a bit like SQL as a DSL, right? It's just the made-up language in which you communicate. All right. There's 37 different types of queries, so they could be things like, even though queries aren't relevant in MySQL or anything like that, but they'll be things like where in, where, or where, you know, all of these different operators, you know, that you can set criteria on. Okay. And queries are intelligent. They score. Everything inside it gets scored. Filters, much the same as queries, except they don't do any scoring. They're just a yes or no. Did this match this? Yes, sweet, we keep it. Did it match it? No, all right, boot it. Really simple in that sense. Best way to show you is have a look at the example. So if we were to search in our hotels for Renaissance, that's all we'd have to do. We'd be putting a GET request across to our hotel documents, and our query. This is called a match query, okay? It's the default query that you can use, and this will suit probably 80% of your cases. So if you listen to one thing in the talk, listen to this. Your query here is a match query, and we're going to search Renaissance against any fields that have been indexed, okay? And it's just going to return us the fields that are most relevant to that, all right? We can get a little bit more complex when we talk about filters in the sense that they look verbose, but we're actually, the reason this is nested is we need a query put across the search. It's a bit boring, but this is just this here is the equivalent of saying where disability features equals 1 or something like that, right? It's just filtering across this. We'll put this into context pretty soon, okay? Just to review one more time, all right? We want to find Renaissance hotels under 150 euros within half a K of BIM house, disability access, Wi-Fi, and above ground level. How would you do this in SQL? There's two approaches. SQL is kind of harder and not as flexible. That's the short. All right. In SQL, it'd be something like this, would you say? Select all from hotels where name, like Renaissance, price is 150 or less, and disability access exists. All right, so we've sort of knocked out a few, but it's going to be slow, and it's not really flexible in the sense that if you've got a slight variance in the terminology or something like that, it's not going to find anything that you're after. So what you could do is add a full text index, okay? And you've got a full text index, and you do a slightly different SQL query. All right, I'm not teaching this side of it, so we're just skimming over what you could do. It lets you do a little bit more, but it's not super flexible, okay? But we have knocked out the majority of the requirements, okay? There's two that we have to knock out down the bottom, which is Wi-Fi and above ground level, which are both optional. So you've got to work out a way to sort of model that in SQL. And you also want something within half a kilometre of here, okay? So we could do something like this. It gets more complex. We're doing a couple of order bys, all right? There's other ways to do it as well. I'm not an SQL Nazi, but something along the lines of this would do the job, all right? It's getting messy. You're prioritizing, it's not nice. You're prioritizing Wi-Fi over ground levels because you're sorting by Wi-Fi, then sorting the equal, scoring Wi-Fi against ground levels and all that. It's a bit messy. But we have done most of the stuff. The only one we haven't done is something within half a kilometre of here. All right. Now, I'm not going to dig into spatial awareness because it's like a whole talk on itself, but it's tricky and it's yucky and it's horrible. And it's also really strict, okay? I don't like it, but let's just pretend in a perfect world we've done it and we move on and we've got all the things that we're after. I like to play devil's advocate. So what if somebody had searched for a Residence Inn, which is another product by a Marriott who do Renaissance hotels? Or what if the hotel was 151 euros? I don't think the person would be that angry about paying €1 more, okay? So yeah, but it's true. It's very hard to do that in a typical relational database. Same thing, what if it was 501 meters away? I mean, that's the difference between me standing here and me standing here. Like, it seems a bit extreme to not show them that option. If you're running a website, you might lose a sale out of that, right? And what if someone cared, and let's face it, no one does, but what if someone cared more about having rooms above the ground level than being provided Wi-Fi, right? So let's talk about how ElasticSearch would do this, all right? We'd populate some data, you've seen that. We would do a thing called a bool query, okay? So this is where we specify things that have to happen, things that can't happen, and things that make something more relevant, right? So if this happens, yeah, it's kind of more important, okay? Don't get too caught up on the structure of this. That's probably another evil thing. It's very verbose, but don't get caught up too much on the structure. This is basically a placeholder for us putting different queries inside each of these holes here. Okay, and you can put anything, a standard match query, which we showed you before, and we're probably going to be doing that. So I would be doing something like this, all right? Once again, don't get caught up on the structure, but we're matching our name against Renaissance, against the name field, and the company field, okay? Just in case they've searched maybe Marriott instead of Renaissance, okay? We've said they have to have disability access, sure. And that if a place has Wi-Fi or has ground level greater than 1, or the total number of floors greater than 1, we're going to boost them higher. Okay, so if you had two things that suffice the first two queries, then it's going to come down to those last two. Okay, and you notice what I've done is I've actually added this little symbol here, which is boosting the name field. Okay, doesn't make it twice as important as company. That everything will be twice as relevant, but it means that it's boosted by a factor of 2, okay? And this is a trial and error thing. But what we've done so far with this query, which was not too complex, but the syntax is new, and I get that, is we've done everything but the last two, okay? Which is the 150 euros and the half a K. So coming back from our last little devil's advocate here, what if we had these two edge cases? Well, just so happens, you can do it in ElasticSearch, and it's fun and it's easy, okay? It really is easy. I feel like a maths teacher. Consider this graph. No, looking over the side here, looking over the side here, we do a special thing called functions. I sort of tapped on them before, but what they let you do is they let you specify a criteria, whatever it be. It could be a geo point, could be price, distance, number, date, any of these things. And you can say, you can specify the center of whatever this is, okay? And you can specify an offset which is allowed, and then a decay, okay? Now a decay is a bit like a boost. It doesn't just magically make it lose 20 points of relevance, but what it does is it's the factor in which it drops off. So if you pictured right at this top part here, in this instance to be 0.5 kilometers, 500 meters, relevance just drops off, okay? But what that means, if something's sitting just here in distance that's really relevant in every other way, it's still going to show up, okay? But you've still done what the user said, and they didn't want to be more than 500 meters away. So something at 510 or 20 is still going to show up. Now, the way in which you control that is you adjusting your decay, okay? The higher you bring that up, the more it goes. Same thing happens with the price, okay? You can say that you want 100, and I don't know why I said 100, because I should have said 150. 10 points for reviewing my slides. If you've got 150, as you can clearly see, and you've got a decay of 20, hit 160, might still show up if it's relevant in other fields, but it's going to be penalized a fair bit, okay? Adjusting that value, it will adjust it up and down. And this is totally dependent on your data. It's trial and error, okay? I'm not going to bore you with this. I promise I wouldn't try and bore you too much. That's what the whole thing looks like. Haha. All right, moving on. If you want to see that in detail, feel free to type that into your browser now, and you can have a look at that query while I keep talking, okay? I'll give you 2 seconds to have a look at that in your own time and get your head around how it's just separate modules, okay? I've got a bunch of resources at the end, which will help you dig into this as well. So, also promised at the start of the talk, we would go through integration with WordPress. No. All right. I wouldn't do that. I wouldn't do that to someone I hated. We'll do integration with Laravel. Sorry if any of you guys have to deal with WordPress. I really am truly sorry if you have to deal with WordPress. But we're going to talk about Laravel because it's fun. So ElasticSearch has a really cool PHP client that kind of abstracts away a lot of this stuff, all right? And it's really easy to install, but you'll never guess the name. It's ElasticSearch, okay? You install that, and you're good to go, all right? I'm not going to run through the Composer installation side of it. 1,000,001 talks on that already. So creating and updating documents is a little bit like what you've seen, okay? But we're obviously wrapping it in PHP arrays. It's taking a little bit of the verboseness out of it, but it's still kind of verbose, and so you're probably going to want to wrap this in some sort of service within your own applications. But it would be as simple as this, and this is going to default to talking to your Elasticsearch running on localhost, okay? You can put in a different host and all that sort of jazz, but not important. We would index, that's the exact equivalent of the put request or the post request that we did before, okay? This works for creating and updating, and that's really important to note because most of you are probably, if you dig into this stuff, are going to have your list of whatever it is in your SQL database, and then you're going to have an extra index purely used for searching, and I'll show you how you can do that. It's pretty simple, all right? So when you're partially updating, you can send just the information that's relevant. For example, the first one I've sent through all this junk, really boring. Second one I've just changed the floor levels because they just whacked another floor on there, right? As you do. I've seen that happen actually. I've seen them just build it up. It's really cool. Deleting it, pretty simple. Delete it, you give it an index, a type, and an ID. And once again, you abstract a lot of this stuff out. You can provide defaults for a lot of these things as well. And so you just calling delete and then passing through your ID. That's much nicer. Searching, kind of simple, all right? Instead of passing through a payload or something like that, you're passing through this sort of a payload, which is a query, okay? You could have booleans and all sorts of junk in there, but at the most simple form, if you did a combination of this and this and this, you've all of a sudden got full text search working, okay? Simple as that. Eloquent. Eloquent is something that I imagine most of us use, and I'm going to run through a little bit how you could integrate Elasticsearch with Eloquent, because it's all good and well hearing someone yap on about all this stuff up on stage, but if you get some examples of sort of kickstart you in the right direction, that just helps immensely, right? So the way I would approach it is one, use repositories, and we've had 1,000,001 talks on that too. And that is really key to being able to put, MongoDB or Elasticsearch as another store, right? So what we could do is we could hook into it. There's a bunch of events that happen in Eloquent when you create something, when you delete something, all of these things, and you can tap into these. I don't know if you've seen these. There's post, so creating and created. Okay, so one happens after, one happens before. We can do the same thing. Just shoot it up to Elasticsearch. Okay, and then it gets really tricky when you want to update stuff, because what you have to do is change all of that to that. Okay, and yeah, it's murder. But jokes aside, it's not that bad, is it? And that is the most simple way. I mean, you don't have to do this whole to-array thing, but you could. That'll send the relationships up as nested objects. It'll all be queryable. It's beautiful. But you can set up custom payloads. You can use a transformer. Or you can abstract till you drop. Okay, but you don't have to. All right. Same thing when you delete. So by doing this, you've essentially just integrated. As long as you have Elasticsearch, you've just downloaded the binary and run it in your terminal. You've finished integrating it, so you have an index that constantly updates. There's other approaches. You could have an artisan command that did it on a mass scale. You could send this up to a queue and have a queue job that runs and talks to Elasticsearch. I would advise against that, because quite often it's quicker just to talk to Elasticsearch than talk to the queue who talks to Elasticsearch. It gets a bit messy, but it's doable. Either way is fine. You could do something in your views. No, I would never do that. Yeah, do it in your views. You just do all this stuff in views. Views for the win. Validation in views. I love it. All right. I'm gonna get knocked off this stage soon. So yeah, as far as the searching side of it, there's two ways you could do it. And one way is just attaching a search method to your hotel model, right? So hotel search Renaissance, or hotel search Renaissance, and pass through your radius of where you want to be or whatever. That's one way of doing it, but it kind of smells, because what you're then doing is forcing your app to have to use Elasticsearch. And let's say, as this stuff does happen, 3 or 4 years down the track, something better comes out, Elasticsearch becomes obsolete. What do you want to do then? Well, if you were using repositories, okay, you could substitute out your main Eloquent repository for something that just does a little bit more on some of your terminology. And the way I would do that is a really cool pattern called a decorator. Now, who knows about decorator patterns? Because I'll approach this 2 ways if most people know. Okay, 3/4 of you. Decorator pattern is it's a way of overriding functionality without just going my class extends the parent class, without direct inheritance. I'll run you through a really quick example of it. If you want to learn more, Jeff Way, I wish he was here, but shameless plug for him again. He has a really cool series on Solid, and he talks in part of that about decorators. And it sounds really fancy, but it's not. I'll show you how it works. It works wonderfully in Laravel, and it's all auto magic. So say we had our standard Eloquent repository for retrieving hotels, right? You might have your create, update, delete, whatever. And then you got search. Now, if it was me implementing this, and I've done this on a few projects, what I would do is I would make that work as best you can, at least, in SQL. Have your app working in a really horrible, crummy way, but it does work, okay? Then what I would be doing is, how you can bind an interface to an implementation. That's how you would actually inject this into, say, a controller or some sort of a service layer class or something. What I would be doing here is making a new repository, okay? This is called decorating. What you do is you make a completely standalone class. You just take the other class as a dependency. And by doing this, we've got access to the original Eloquent repository, which we've hard-coded that we wanted, right? And then we're just going to bind to our Elasticsearch repository. Now, right off the bat, if we were just to pass everything through Eloquent, nothing would change. And we would do that for every single method, except for our search. Okay? So this is where we'd actually talk directly to Elasticsearch itself and probably produce something along the lines of this, a bit more in detail. You might be caching it, I don't know. You probably don't need to cache it. Elasticsearch is fast. So you've got your results, you do your query that we were just showing you, search by name, whatever you want to do. And then you would this is how I would do it, because we're decorating, the idea is the class that's using it doesn't need to know or doesn't need to care if you're your sort of overriding functionality. So if I was to bring back an array or even bring back an Illuminate database, like a collection, I could actually pretend that I've loaded these from the database, even though I've really only hydrated them from what's come back from Elasticsearch. So say you search for an instance and you get this array that comes back from Elasticsearch, which has got your data in it, right? You would then build your hotel object. You would tell it that it exists, which is how it knows whether it came from the database or not. So we're kind of lying to it. And yeah, forgive me. And you return it back. And this array map basically it just transforms what we had into something else, okay? If you want to have a look a little bit more into this, feel free to open up this. I haven't put the repository up yet because you guys are like using too much internet. So when you do, I'll have a working example up here. You can dig into more. I'll have it up tonight maybe. And yeah, so if you want to just make a note of that now, I'll give you 2 seconds to do it, and you can have a look at that working app and see how it would actually work. Okay. Now, that sort of comes to the end of the practical side. I'm sort of going to wrap up now, but I just want to give you a couple of reasonings as to why I would have chosen such a product, okay? Compared to the other main players, Elasticsearch was always built from the ground up to be real-time and distributed. It wasn't sort of an afterthought, oh, this kind of works, but we need to make it scale, right? It just works, it handles concurrent read and write requests a lot better than the other guys, okay? And the reasoning is as to how it distributes its indexing across the more instances or nodes you have running, the better it can read and write concurrently, and you don't get this bottleneck. You look at some other systems, you might be indexing on a bulk of, maybe 1,000 products or 1,000 entries or documents. You're going to find your searching is going to just like go horribly slow. But in Elasticsearch, that isn't the case. It doesn't really even affect it. It's easy to run, download a binary, execute it. You can set it up as a service and all this sort of stuff. And yeah, I mean, the simplicity of it and JSON over REST, I just think it's really nice. Why I chose Elasticsearch over something else. This isn't a bash on any of these things. I mean, I couldn't write any of these things, so good on all of them. But Solar, Enterprise, I don't like XML. XML is verbose, and I could argue almost to any of you that I can do anything in JSON that you can do in XML. What else? Yeah, Sphinx. Sphinx has a funny DSL, and it wasn't really aimed at being a real-time search engine. It was the sort of thing that you would you query and get these things out of it, aggregate all this data as a background job sort of thing, and then you would have it stored again, maybe cached or in another relational database. So that was the reason I dug into this over the others, but the others are good too, all right? There's a few things in this talk I haven't told you about because this is new concepts, and if you're interested, it's really fun. If you're not, you're asleep, and there's probably only 80% of you are asleep, so it's good. Still got some of you. Partial matching, so we can actually do really fancy things like search within words and that sort of thing. Autocomplete is a breeze with it, and it's fast. It's about as fast as you can type, okay? We're talking milliseconds to search thousands and thousands of records, as opposed to, 100, 200 milliseconds, which you might be getting out of a MySQL database. Fuzzy search is important, okay? So say you misspell words a little bit or horribly wrong, we can actually know that you were talking about something else or make the assumption that you were. Or even if you search the right thing and there's something indexed incorrectly, well, we can do that as well, but it's a little bit less relevant, okay? Fine-tuning analysis. There is so much you can do. I haven't even told you about schemas or anything. You can set up a lot of configuration, but you don't have to, okay? The best way is to dig in, have a play, and then grow, okay? And one of the really big ones, and I really would love to have talked to you about it, except that you've got to understand a whole bunch of other crap first, is analytics, okay? Elasticsearch, because of the nature of its inverted index, okay, it lets you, it makes it very easy to work out, how many red cars there are, or how many hotels with 11 floors there are within the scope of another query that you're doing, right? Or it may let you do things for reporting that, you imagine building dashboards and you're doing one query, getting all this data back. It's like instant. You're not trolling through tables on a background job and building up some, cache or something like that. It's beautiful. It's really quite simple. It's all real time. There's no dicking around. And I promised myself I would never do this, but I love being cheesy. One more thing. Yeah, sorry. I was kind of excited about this because I only thought of it today, but I'm going to be bringing this, or hopefully if Taylor lets me, I've spoke to him and he said he would, bring it into Laravel Homestead. So when you install Homestead, you literally, you'll update your Homestead boxes and you'll have access to ElasticSearch within your Homestead setup. So there is nothing to do except require ElasticSearch, in your projects, and you can start playing around with it. So with that, in conjunction with the repo that I'll have set up for those of you who wanted to look at it, should really get you off to a good track. Further learning, obviously ElasticSearch is really good. It's a good spot to start learning about ElasticSearch. You've got this book down here, which is really cool. It's only just come out, I think, like maybe 2 weeks ago or 3 weeks ago. It talks about everything. Starts from the most basic, more basic than I've covered today, and 700 pages, a lot of coffee and beer later, you get to the really complex stuff. And you've got that link to the repository again. So if any of you want to make note of that, feel free to do so. But they're really good and they're worth it. This book is actually free to read online, but if you start using it, pay the $20 and buy the book. All right. Aside from that, thanks for having me. And I've talked very long on purpose so that you can't ask too many questions. But yes, who has questions? We're looking around. Yep. Oh, no.
Me first. I got to get you.
Game on.
First and foremost, thanks a lot. Obviously, we had a chat yesterday about it, but that was really, really cool. There's one thing that you did in the presentation whereby, as part of the event, once a model's been created or persisted to the database, that you're then creating the Elasticsearch data.
Yep.
The example you gave there was actually using a two-array call. That I find really cool. But do you see any hiccups or issues with actually persisting the entire model and its related data to Elasticsearch as well?
Sure. We didn't talk about it at all because it's a bit complex, but when you are sending data up, you're sending a name or an array or something, you can actually specify in Elasticsearch when you make the index, which you can do manually, whether something is searchable, what type of data it's expecting. It just guesses that based on what you send it. But no, you can. The more data you have, the more terms you have, the slower it becomes, right? But for example, I read a statistic to cut the word the, right, THE, out of 1 million records, right, would save 4 megabytes of space. So it's not so much the storage, it's the performance side of things. So there would be nothing at all wrong with that, I don't think, as long as you set up a schema in Elasticsearch to say, all this extra data can be stored in here, but we don't really want to be able to search on anything except for maybe the title, the description, maybe some tags or something. You might have like hip or basic or something as a tag for a hotel. That's something that you could absolutely do. And there's nothing wrong with sending the to array up there. I mean, you could have another method like to Elasticsearch. You can make another interface Elasticsearchable, right? And you have to implement to Elasticsearch and send up the payload for Elasticsearch. But as long as you've set up your indexes, which totally out of the scope of this topic, it's nothing wrong with it. That help? Sweet. Sharon. Who's next? Over here. Yeah, I'm scared. Be nice.
So I actually had a pretty similar question. So I'll make it more specific.
Yep.
You've had some experience putting it into production, it sounds like.
Yeah.
How big are the indexes? So say for your example where you had 300,000 records, is it like in the megabytes range or gigabytes?
Okay. That's a good, I've never actually looked how physically big they are. I've never looked, but performance-wise, I haven't noticed a difference between 100 records and 300,000. For example, with that, that is referring to indexing of addresses and things like that, and it was a fair bit of data in there, and the performance-wise, it wasn't too bad. But it definitely wasn't into the gigabytes because it would have been something we would have picked up, and didn't even notice it. We haven't noticed it. That's a good question though. I'd actually like to know that now.
Okay. One more question, sorry.
Hey.
I'd like your quick opinion, not too much into detail.
Sure.
If you had an existing Laravel app that did everything and you just wanted to integrate ElasticSearch on one particular object that already has a lot of connections in MySQL and everything. How would you approach it? Would you save that object with all those connections, or is there a way to somehow make it work with MySQL so you do only search and then make connections from MySQL, maybe?
So you mean when you're doing the search to then add it to Elasticsearch like that?
Yeah, first do search on ElasticSearch,
Yep.
and then those returned objects somehow fetch from data
Yep.
from MySQL, so you don't have to save everything in
Sure,
ElasticSearch.
absolutely. There's two ways of doing this, and actually I think Kirk asked me this yesterday. So there's two ways you can do it. One is store all the data in Elasticsearch and rehydrate your models. The second one is just store IDs in Elastic. Obviously the searchable data, but your IDs, maybe like a post ID or a whatever, right? Get that back and then query your own database for those objects and go for gold, right? You could do an eager loaded query and it would be kind of fast. It would still be faster to do it that way than to search a huge amount of data.
Yeah, that's what I thought.
In MySQL, it'd be quicker to do it in Elasticsearch, grab the IDs and just grab those out of MySQL. That's quick. That is perfectly fine. If you do it the other way, where you don't actually store relationships in Elasticsearch, you can pull and hydrate your model back, and it actually works in the sense that you can pull it back. You want to grab a relationship, then it'll do the lazy loaded query. That works as well. But no, the way that you're sort of hinting there, that's a perfectly acceptable way of doing it. Nothing wrong with it. Any more?
I think that's all the time we have, but thanks so much, Ben.
All right, thanks guys.